Okay, what we'll do today, if you see the syllabus for this unit number 2, it is divided into two parts. One is based on MOSFET AC circuits, and half part is based on the feedback circuit. Okay, so in the last lecture, we have studied CMOS, right? MOSFET as a switch, MOSFET as a resistor and diode. Then we have seen CMOS structure, its working, and how CMOS acts as an inverter. Then we have to learn the CMOS characteristics and current sink, current source, and how MOSFET amplifier operates with different types of resistive load. Now, before that, today we'll start the second half. Okay, and then we will, till that time, you simply revise your how MOSFET works as a resistance, as a diode, as a switch, and how CMOS, what is the construction, how is the construction of CMOS, and how CMOS work as an inverter. You just revise it, and then we will again revise the same portion, and then we will go for its transfer characteristic, because it is little bit complicated to understand. So you have to revise the things, and again we will continue with the uh, MOSFET circuits. Now today we will see an important topic called the structure of feedback amplifier. Okay, we'll see the structure of feedback amplifier. Now, what is a feedback amplifier? Amplifier we have studied as all. What is an amplifier? You know that amplifier is a device. You have defined it. Amplifier is a device where if you give a signal to the input, it appears in the amplified version, means in the increased strength, that is increased magnitude. However, frequency of the signal remains same. So if I say this is an amplifier, so amplifier is a two-port device, and it has we apply input signal in between these two terminals, and we take the output in between these two terminals. So here we used to apply input signal, and here we used to take output signal, and this is our amplifier. Okay, now you know now how many terminals are there? 1 2 3 4, 2 input, 2 output. So you have studied transistor as amplifier, and we have studied MOSFET as amplifier. So you know there are only three terminals, like drain, gate, and source. In transistor we have emitter, base, and collector. So what we do, we make one of the terminal as a common, and then we use it as amplifier. So while using FET, MOSFET, or transistor, we make the one terminal as common, which will be present in both sides. So then I used to apply the input signal between these two terminals, and we take output between these two terminals. And this way we form the amplifier. Okay, so here we will give input, and here we will take output. And we call this as an amplifier. This box is an amplifier. So you have to give input to the gate, output to the drain if you are studying common source amplifier, and source terminal is common. Am I audible clearly?
Yes, ma'am.
Yes, ma'am.
Source terminal is common. We have defined what is amplifier, that it takes a small signal and increases the strength of the signal, or it increases the amplitude of the signal. If you apply a signal here which is weak or having small amplitude, So you will get here the output, which is enlarged version of this. Okay, if I plot this signal with respect to t, so you will find that magnitude, suppose you are applying 1 millivolt at the input, that is 1 into 10 raised to minus 3 volt. So you may get the signal here of 1 volt, where 1 millivolt has been amplified to 1 volt. So this is voltage, or I'll say this is amplitude, and this is time. As we have studied MOSFET common source amplifier, you know that there is a phase reversal. So phase shift may happen. What about frequency? It remains same. Frequency remains same. Okay. So amplifier is not changing any frequency. It will keep the frequency as it is. Now this is what we are talking about an amplifier. This is what an amplifier is. So I'll rather say it's the amplifier without feedback. Amplifier without feedback. Okay. Now, when the term feedback comes, what is the meaning of this? This is input side, this is output side. If you connect the part of output back to the input, we will call it as a feedback amplifier. Okay. If you connect the part of output back to the input, we will call it as feedback amplifier. So here I will try to show you what is feedback amplifier. This was our case. This was our case. This was our input and this was our output. This was the amplifier. Now, if I connect the part of output back to the input, okay, if I connect this output back to the input, what I have done, output is connected back to the input. I will call it as feedback. Okay, what I will call it as feedback process. Feedback means connecting part of output back to the input in amplifier. Then that amplifier is called as feedback amplifier. Have you understood the concept of feedback? Connecting part of output back to the input is called as feedback. Yes or no? Have you understood this term? Feedback?
Yes, ma'am.
Yes, ma'am.
Everybody. What is the meaning of feedback that you understood? So whenever I'll be connecting some part of output back to the input, I will call it as feedback process. And if I'm applying this on uh, the amplifier, I will call it as feedback amplifier. Is it clear? Now here I am showing you the feedback amplifier. Whatever I have shown you on this whiteboard, so there is a single amplifier. Now if I want to apply feedback process here, what I will do? So this is A means my amplifier. For this amplifier, I will say the gain of the amplifier is AV. If suppose this is a voltage amplifier, I may call the gain of this amplifier as AV. If this is a current amplifier, I will call this the gain of this amplifier as AI. If this is a trans resistance or trans conductance amplifier, I will, please keep joining in time. So I will call the gain I'm using this letter A to indicate gain. Then I will use the letter V or A depending on if it is a current amplifier or voltage amplifier or transconductance amplifier or transresistance amplifier. So in general, if I want to show for another type of amplifier, I'll be using the term. So if I want to use it for normal amplifier, I'll be simply using AV, AI, GM and RM. If it is a voltage, current, transconductance or transresistance amplifier. What are these things? I will be explaining you further. And if I am giving feedback to the amplifier, I'll writing here F in the suffix. So A, if I write A, it is gain without feedback, and if I use this AF, it is gain with feedback. Okay, so remember this two, gain with feedback, gain without feedback. Now, when we provide feedback to an amplifier, so this is the amplifier. Look at this block. I have highlighted it. A is written. So this is the amplifier. Whatever is available at the input, I will call this the signal as Xi. What is input to the amplifier? The signal which is input to this amplifier, I will call it as Xi. So this is the signal Xi, input signal Xi, which is going to this amplifier. Fine. And this amplifier is producing the output signal XO. Okay. Now, if I say that amplifier A, amplifier is having gain A, and if I give it input as Xi and I take output as XO, what is the relation between this? You know, gain is the ratio of output upon input. It may be voltage gain or current gain, anything. So, whatever I am getting output XO is equal to A times Xi. Got it? Suppose gain of my amplifier is 10. It means I will get output signal XO as 10 times input signal Xi. Right? It means if I give 1 millivolt at the input, so how much output I'll get? XO will be 10 times the input signal, that is 10 millivolt. Right? So gain is indicating you how much time your signal will be signal can be amplified by using the amplifier. Okay, so Xi is the input signal and XO is the output signal. What is the relation? XO is equal to A times Xi, where A is the gain of this amplifier. Got it? Is it clear? I am talking only about this block without feedback. Have you got it? What is, I am considering only this block A. So I am giving xi at the input, I am getting xo at the output. Forget about what is this xi minus xf on. Forget it. Have you understood this?
Yes, ma'am.
Everybody? Everybody?
Yes, ma'am.
Okay. Now, when I apply feedback, what I do, this is the output XO. Now, this is your load, okay, load resistance or whatever load you have connected. So, your output is available here. We take this output and give to some network called as feedback network. We connect here. So, now another block comes. This is called as feedback network. And beta, like A is the gain of amplifier, beta is the gain of this feedback network. What is beta? Beta is the gain of this feedback network. Okay. So what we are giving input, this is the input. What beta network is receiving, what feedback network is receiving, this output of amplifier, it is given to the input of beta network. And what beta network is providing, that we are connecting back to the amplifier, how we will see. So beta is receiving your input and here it is providing its output. Let us call it as, what is input to beta network? This XO. Okay. What is input for this? XO. And what beta network is producing, that is XF, beta network or feedback network. So it is producing XF. Clear? Please zoom the screen. So what is beta? Beta is the feedback gain, can be calculated as, what is, it is also, wherever you are defining gain, it will be always the ratio of output signal to input signal. Okay, output by input. Now what is your output? What is the output of beta network? Please tell. What is the output of beta network?
Except
XF. What is the input to beta network? Just a minute, I by mistake I wrote this as, this should be input. Okay, so output of beta network is XF and input of beta network is XO. Okay. So what is the feedback gain or gain of this feedback network? Feedback, it's a XF upon XO. So I can say the output of feedback network is equal to beta times XO. Okay, clear? Everybody, is it clear? What is beta and what is O? When
Yes, ma'am.
I'm talking about A is gain without feedback. And when we will calculate the gain with feedback, we will call it as AF, like here it is given. Okay, we will call it as AF. So now what we have done, our output is available at the amplifier. We have taken it, applied it to the feedback network, and here the output is present, XF is present. Now, when I have to give this back to the input, now consider the feedback network. Now consider the feedback network. So when I say feedback network, I need this portion. What I will do, I will take the part of output or this XO signal. It will be given to beta network or feedback network. Feedback network will provide its output and that output will be given to the block called as mixer. Okay, this block is called as mixer. Okay. What this mixer will do, it will take the input signal. Now, when I am forming a feedback amplifier, I will not give my input directly to the amplifier, like the case I have discussed here. Here, the input was given directly to the feedback amplifier, to the amplifier. Input was given directly. So In feedback amplifier, what we do, we will not give input directly. We will not give the input directly, but we will give it through the mixer. Understood? Oh, annotation has gone. Okay, no problem. Annotation is gone. Here I have explained you what is gain of amplifier without feedback. That is equal to XO upon XI. This is without feedback. And with reference to this, I have also explained you that output is equal to A times Xi. Right? Similarly, I have explained you what is beta. It is the feedback gain, and it is the ratio of output of feedback network to input of feedback network. So this is equal to output of feedback network is XF and input of feedback network was XO. So I can say that XF is equal to beta times XO. Fine. Now when I have to apply feedback, I will consider this network. So I will not give the input directly, but I will give the input through mixer. I will give input through the mixer. So this is the mixer stage. What is this? This is a mixer. Here I will apply, this is source, means the device from which I am input signal. I am inputting signal. So this source, it will give input signal X that will go to the mixer, and the feedback signal will also go to the mixer. First of all, what will happen? The source will provide signal access to the mixer. It will go to the amplifier. It will be amplified. Once the output is available at the output of amplifier, this will be given to the input. Either complete or part of this will be given to the beta network, and beta network will produce some output. So this is a feedback signal and this is the original signal. They will be mixed here and it will be provided to the amplifier. Now when I say feedback amplifier, this input here Xi, it is of two types. It is a mixture of Xi and Xf. Okay, Xi and Xf. So it is the sum of Xi plus Xf. Sorry, not Xf. It is the sum of Xs plus input signal Xs plus feedback signal Xf. Okay. So what is the input? This we will talk now with feedback. Okay. This gain was without feedback. This was without feedback. And this is with feedback. Okay. So in this case, what is your Xi? Your Xi is now changing. You know, Xi is the input to the amplifier, but now it is the combination of two signals, the signal which is coming from the source plus the signal which is coming from the feedback network. Got it? When you do not apply any feedback, your signal is Xi, that is directly your Xs. But when you apply feedback, the signal which is going to the amplifier is combination of sum of two signals, the signals as well as feedback signal, the original signal and the feedback signal. Got it? Is it clear? So here, if you apply this, if you connect beta network and make such connection, input to the feedback amplifier become Xs plus Xf. Is it clear?
Yes, ma'am.
Okay. Now, I told you that it becomes the combination of two signals. Now let's see. This is an amplifier. Now you understood the loop, how it is. First, so this is the amplifier without feedback. When you want to make this as amplifier with feedback, you connect the beta network. Okay. Then this is the output of amplifier. Then it will go to the beta network. Okay. Then beta network will produce some output. It will go to the mixer. Okay. This is the mixer. Once you complete this, it becomes a feedback amplifier where from mixer is getting the signal. So XS is the input signal, your actual input signal XS, and this is a feedback signal XF, and their sum is going to the amplifier. Clear? So here you may have it, the output load present. This is feedback network. In short, I'll write beta network. Suppose I am writing here two important cases, and we will be talking about two very important definitions: positive feedback and negative feedback. So first, let's say what is a positive feedback. There are two types of feedback. So feedback is positive feedback. One is positive feedback and another is negative feedback. Positive feedback and negative feedback. These are the two types of feedback. Okay. Now, when I will call feedback as a positive feedback, I told you that input which is going, XI which is going to the amplifier is the combination of, is the sum of XS and XF. So when the input signal, which is our input signal XS, this is the input signal, and feedback signal, this is a feedback signal. So when the input signal and feedback signal both are in phase, then the feedback is called as positive feedback. What is the definition of positive feedback? When input signal and the feedback signal are in phase. You understand in what is in phase and what is out of phase. Okay. Like suppose this is, there is no phase shift. If this is the input signal, the feedback signal is also in the same phase. There is no phase shift. So when the input signal and feedback signal are in phase, the feedback is called as positive feedback. And when the input signal and feedback signal are out of phase, the feedback is called as negative feedback. If there is any phase difference, if this is the input signal and this is the feedback signal, let's say it is starting with some phase difference, okay, or it is having the phase shift, okay. So if there is a phase difference between, or I'll say if they are out of phase, then the feedback is called as negative feedback. When input, that is XS, and feedback signal are out of phase, then that feedback is called as negative feedback. Understood this? Is it clear? What is a negative feedback and what is a positive feedback? Everybody please unmute yourself and define. First of all, what is feedback? You have to define three terms: feedback, positive feedback, negative feedback. Everybody please unmute yourself. Somebody tell me what you mean, what do you mean by feedback?
Connecting part of output back to input is called as
Very good, very good. Connecting part of output back to the input. How many types of feedbacks are there?
Two.
Two.
What are that?
Positive
positive
feedback and
feedback and
negative
negative
feedback.
How you define positive feedback?
An output signal and feedback signal are in phase.
Correct. And negative feedback?
input signal
When
and
input
when
and
input
feedback
signal
signal are
feedback
out
signal
of
are out
phase.
of phase.
Very good response, students. Please give the response like this. Okay. Now, when I say both are in phase, my this thing xi will become xs is our signal plus the sign of the signal will be xf will be plus because they are in phase. And when it is negative feedback, my input signal is going to become xs, that is input signal plus now because of feedback there is a phase shift, so we represent this signal by minus. Okay, so what this will be xs minus xf. I'm able to write this. Okay, xs minus xf. Understood? If it is a positive feedback, then these are additive, and if this is negative feedback, then it is subtractive because there is happening phase reversal. Okay, now how the what is the gain of a positive feedback and what is the gain of negative feedback? This should be xs. Okay. For a negative feedback, this will be xs. Now let us derive this equation. I'll use again the whiteboard. Derive the equation for gain. See, positive feedback and negative feedback. I'll again tell you one important question which examiner will ask you, that positive feedback has different advantages, negative feedback has different advantage. The very important advantage of positive feedback that its gain is very high, and the disadvantage of negative feedback that its gain is very less. When you want to use amplifier, what is your requirement? You want to get maximum output, right? You want get higher output. So for that, the gain must be high, right? If you want maximum output, the gain of amplifier must be high. So positive feedbacks are giving you very high gain, okay? High gain. Whereas negative feedbacks are giving you lesser gain. But still, for amplification, we prefer negative feedback amplifier because it is having, these amplifiers are having many other advantages. And positive feedbacks, if I want, let me tell you the application of positive feedback. Positive feedback amplifiers are mostly used in oscillator, where oscillator, and negative feedbacks are preferred in amplifier. Okay, negative feedbacks are preferred in amplifier. So let's see, let us derive the equation for gain of these amplifiers. What is gain? What is gain?
The ratio of output to input.
Now I will find voltage gain. So it is ratio of output voltage to input voltage. Output voltage to input voltage. So what is the output voltage, and or in general I will calculate so that I can have it in terms of X. I want it a feedback, so I will call it as feedback. So first of all, what is A without feedback? It is the ratio of output of an amplifier XO upon input to the amplifier XI. Right? Correct? What is the gain without feedback? So I have to consider single amplifier A, this amplifier. So my input signal may be Xi and output signal may be XO. It may be voltage or current. So I can have my voltage or gain or current gain as ratio of XO upon Xi. This is gain without feedback. And now if I want to find gain with feedback, so it will be AV divided, sorry, I will call it as AF, gain with feedback. Let us consider first positive feedback. So with feedback, it will be, if I use same notation, XO upon XI. But what is Xi in case of feedback? In case of positive feedback? In positive feedback, what is our Xi becomes equal to? It is XS plus XF, right? Original signal plus feedback signal. Because it is a positive feedback, I'll write here plus XF. So this Xi will be replaced by XS plus XF. Agree?
Yes.
Is it correct? Okay, so I
Yes, ma'am.
rewrite AF, that is gain with feedback, is just a minute. Gain with feedback AF is equal to XO upon XS plus XF. So my signal can be either voltage signal, so I can replace this X by V, or it may be a current signal, so I can replace this X by I. In general, I wrote here XO. Okay. What I will do now, I will replace this XF XS. Sorry, uh, one mistake. XI is the signal going to the amplifier. Look at the feedback amplifier. When I say XI, it is amplifier without feedback. Now, when I want to consider amplifier with feedback, my input signal is what? XS. या सिस्टीमला इनपुट येणारा सिग्नल कुठे आहे? एक्सेस आहे. त्याच्यावरून हा तुमचा XI बनणार आहे. आर यू गेटिंग? XI is the input to this amplifier without feedback. But when I consider feedback, my incoming signal is XS. So I will consider here input as XS. So I will not use the same. Okay. So input is here XS. Got it? Yes. When I consider amplifier without feedback, it is XO upon XI. And when I consider amplifier with feedback, then it is yellow color, that it is XO output divided by this input signal. When I consider without feedback, so this output upon this input. And when I consider feedback, so XO, that is output upon this input. Okay, original input. Is it clear to you? What should be the input to be considered? XS. Now, so XI is equal to XS plus XF, that you know. From this, I can say, therefore, what is my XS become? XI minus XF. My input signal becomes Xi minus Xf with this. Because you are using positive feedback, so in positive feedback, amplifier's input becomes sum of the signal and the feedback signal. Therefore, you can say Xs becomes Xi minus Xf. Therefore, I write again that AF feedback gain is equal to XO divided by Xi minus Xf. What I have done, I have substituted this XS. This XS, I have said XS is equal to Xi minus Xf, and I substituted the value of XS in this equation. Let's call this as 1. Let's call this as 2. Okay. Now what I do, AF is equal to, I divide every term by Xi, XO. Xi. This term I'll divide by Xi. These two terms also I'll divide by Xi, so that it will be scaled by same, will not be changed. Okay, what I have done? AF is equal to XO upon Xi plus XF. So every term I have divided by Xi. Now what your AF becomes? Please tell me. XO upon Xi is what? XO upon Xi is what?
A.
A. Correct. Xi upon Xi will be 1 minus XF upon Xi. Now what is XF? It is feedback signal. Okay, XF is the feedback signal. And what is that feedback signal equal to? I'll be right here. XF is the feedback signal. So it is the ratio of output of feedback network divided by input of feedback network. I'll call this equation as T. So what is output of feedback network? Sorry, what is the output of feedback network? It is, sorry, this is not XF. This is our beta. We define feedback factor beta as output of feedback network divided by input of feedback network. So what is output of feedback network? XF. What is input to feedback network? You know, it is the output of amplifier. So XO. So beta is this. Therefore, what is your XF? XF is equal to beta times XO. Okay. Call this as 4. So I'll put this value in 3. Put XF in equation 3. So what I get? What is AF equal to? A divided by 1 minus, instead of XF, I'll write beta time XO divided by XI. Okay. What is this? Again, I can simplify this as A upon it will be A upon 1 minus beta, and what is XO by XI? It is A,
A.
right? So I can say, what is the gain? Gain with feedback AF is equal to A upon 1 minus A beta. What is the gain of feedback amplifier? Positive feedback. This equation we have derived for positive feedback. Okay. So see, gain of positive feedback, how much it comes? AF is equal to A upon 1 minus A beta. Okay. Now A is a higher quantity, but beta lies between greater than 0, less than 1. Okay. So beta may be 0.1, 0.01, whatever you set.